In this section, you will read to passages and answer comprehension questions about each passage. You have 36 minutes to read all of the passages and answer the questions. In the exam, when you want to go to the next question, click the Next button. You may skip questions and go back to them later, as long as there is time remaining. If you want to return to previous questions, click on the Back button. You can click on Review at any time, and the review screen will show you which questions you have answered and which you have not. However, this is a mock test, and you cannot use any buttons. You should read and answer the questions within 18 minutes for each passage. In this section of the test, you will hear dialogues and academic talks, and you will be tested on your ability to understand them. You will hear each dialogue and academic talk only once, and then answer questions after each is finished. The questions ask about the main idea, supporting details, and the way the speakers use language. Answer each question based on what is stated or implied by the speakers. While you listen, you may take notes. You can then use your notes to answer the questions.
Hello, Professor. I just got your message and I wanted to reply to you in person.
Hello, Martin. Come on in. Thanks for dropping by. I know my email was a little vague, so let me just clarify my request. I heard about some of the work you did last year for Professor Connolly on comparative legal systems, and I was wondering if you'd consider taking part in a research project I'm organizing.
I heard some people talking about this in the grad student lounge. Something related to Latin America. It sounds interesting.
Now, it's no simple task I'm talking about here. You will have to write an honors thesis to prepare for the project.
Really? A thesis? I don't know if I can participate, ma'am. I'm actually pretty busy right now. I'm preparing to enter law school.
I understand. But before you say no, I want you to give it some thought. It'll be a really engaging project, covering topics in economics and international law. In your case, it might be of even more help. After all, this kind of experience is really valued by law schools because it involves analytic projects.
It does sound like a great opportunity. I hadn't really looked at it that way. I had known about the project earlier, I might have had time to prepare for it better. Also, I'm not sure I'd be a good addition to the project team.
I wouldn't have asked you if I thought otherwise. Your work for Professor Connolly proves you to be intelligent, resourceful, and a quick thinker. And even though this project focuses on material that's unfamiliar to you, I think it would really help your analytical skills, which are a must if you want to enter and do well in law school.
Well, when you put it that way, Professor, I guess I can't really say no. Okay, I guess you can count me in. What do I have to do first?
Well, I'd suggest you get some advice from professors who can help you find a topic for a thesis paper. They can give you recommendations about narrowing down your thesis, as well as how to research it.
Well, I did write a paper about the economic success stories of Central America for my Latin American history class. The professor who was leading that class gave me an A. I think he could probably help me.
He's definitely a good place to start. Why don't you make an appointment to consult with him?
I think I will. Thanks, Professor.
It'll be a really engaging project, covering topics in economics and international law. In your case, it might be of even more help. After all, this kind of experience is really valued by law schools because it involves analytic projects.
It does sound like a great opportunity. I hadn't really looked at it that way. For today, we're going to discuss a very interesting phenomenon. It's known as black clouds, and, well, it has something to do with volcanic eruptions. Can anyone tell me first where lava is ejected?
Into the air and onto the land, I suppose.
Right. But that's it?
Well, there are underwater volcanoes, so I'd have to say that lava is also ejected onto the bottom of the oceans.
Absolutely. So, what do you think? Is there any way that volcanic eruptions and other underwater phenomena can be probed? Well, actually, we do have maps of the bottom of the ocean, so scientists have a pretty good idea where the mid-ocean ridge volcanoes are located. And, sonar was used to map out the ocean floors. By the way, do you all know what sonar is?
It uses sound to give us a picture of the ocean depths.
That's right. Sonar stands for sound navigation ranging. If you've ever watched those submarine movies, they always have this ping sound. A kind of transmission thing. Well, the length of time between those pings can tell the navigator just how far the ocean floor is. So using sonar alone, you can come up with a pretty good image of the hills and valleys that make up the ocean's bottom. But, see, if you want to make a careful study of underwater phenomena, well, you're going to need a submarine.
Well, Professor, I don't mean to interrupt, but, well, I think when a submarine goes too deep, it begins to crack and break up because of the pressure being exerted on it by the ocean depth. So, how could a submarine possibly go deep enough to allow scientists to observe these underwater phenomena?
Well, yeah, actually, that did happen in the old days. The pressure on the sea floor is about 6 times higher than on the surface of the sea. Fortunately, new and special materials and equipment are available for today's submarines. So, modern submarines can observe some pretty fantastic phenomena, such as black clouds. Let me describe for you how they form. Okay, so scientists have been sending down exploratory missions, and on one of these missions, they saw what appeared to be black clouds rising from the ocean floor. Now, the environment for this interesting phenomenon is the hydrothermal vent, which, as you all know, is simply a geyser on the ocean floor. These vents continually emit super hot, mineral-rich water. Well, it's this water that provides sustenance for organisms that live near the ocean floor, like tube worms and giant clams that ingest minerals. Just to give you an idea how rich this water is, tests indicate the presence of sulfur, copper, gold and iron. Actually, the water coming from these hydrothermal vents is the source of the world's richest ore deposits. So, anyhow, this vent water helps form black clouds. How? Well, when a volcano erupts, it starts spewing out lava onto the ocean floor. Now, this stuff is really hot. About 350 degrees Celsius, but the ocean water is pretty cold. Relatively speaking, something like 0 or 1 degree Celsius. So when hot lava touches this icy cold seawater, the surface of the lava quickly forms a crust of rock. Now, here's where the mineral-rich water spewing from the hydrothermal vents comes in. The sulfide minerals from the hot water kind of grow, or rather, crystallize right there on the volcanic rocks. And as they continue to crystallize, they form this hollow, chimney-like structure. It's through this structure that the hot water keeps spewing out. Then this vent water mixes with the cold ocean water, and the minerals contained in the hot water begin to precipitate, separate into particles. Well, this makes the vent water appear black, that is, the mineral particles make the water appear black. They kind of look like black clouds. So scientists saw these black clouds when they first observed the phenomenon. And that's basically why these sulfide chimney structures are called black smokers. Can anyone tell me first where lava is ejected?
Into the air and onto the land, I suppose.
Right. But that's it?
So, how could a submarine possibly go deep enough to allow scientists to observe these underwater phenomena?
Well, yeah, actually, that did happen in the old days. The pressure on the sea floor is about 6 times higher than on the surface of the sea. Fortunately, new and special materials and equipment are available for today's submarines.
Today we're going to talk about palynology, which is the study of microscopic organic particles, particularly those blown by the wind. These particles are called palynomorphs. And as you can probably guess from the word, organic, they derive from living things. Let's see. Like pollen grains from plants. These tiny bits of matter get scattered all over the earth, and they become trapped in various deposits, such as ice and sediment. A convenient characteristic of pollen, in fact, palynomorphs in general, is that unlike the majority of organic materials that easily break down before they can become fossilized, it tends to persist intact for extremely long periods of time under a wide range of conditions. Also, pollen can be studied fairly easily because, plants produce them in great quantities to ensure reproduction. This makes it easy to collect samples. Now, what do you think the analysis of pollen can tell archaeologists? Well, believe it or not, it can tell us a lot about objects and people of the past. Alright, then. When archaeologists sift through the soil at an excavation site, they find pollen grains in the soil attached to a particular artifact. By analyzing the pollen grains, they can get a reasonably good idea of how old the object is. I'll give you a specific example to help you visualize how it works. Next to a lake in northern Europe a few years back, A team of archaeologists were excavating an area and came across a large bone which had obviously been fashioned into a spear at some point in the distant past. By analyzing the pollen found in the soil attached to the bone, palynologists tentatively determined that the surrounding sediment had been deposited around 7000 BC. They know this because that is around the time that pines were being replaced by deciduous trees due to the warming climate in the region. Pretty cool, huh? The only downside of using this method of dating is that it lacks the pinpoint accuracy of some other techniques.
Yeah, I was kind of wondering about that. Nowadays we have radiometric dating, right?
You're one step ahead of me on this. Since radiometric dating was discovered, pollen analysis is typically used in unique circumstances or merely as a complement. Remember how I mentioned that pollen grains last a very long time? Well, if an archaeological object is too old, common forms of radiometric dating won't always work. But palynological tests still can give us a really good general idea about chronology, even with deposits that are millions of years old. Okay. In addition to the dating of specific artifacts, palynology can tell us about the historical interaction between humans and their environment. When a human population starts to expand into a region, the local plant life usually undergoes a lot of changes. Forests are cut down, domesticated animals graze on grasses and shrubs. Well, you get the picture. For example, soil samples collected in Belize show that prior to 2500 BC, vegetation in the region was typical of that found in a tropical rainforest. However, from 2500 BC onwards, the samples show increasing signs of deforestation. Less pollen from trees and more from grasses and weeds. This is a clear indication of human settlement. In addition, pollen from plants commonly cultivated in South America, such as maize and chilies, appear with great frequency in subsequent sedimentary layers. By analyzing the palynological data, archaeologists are able to develop a better understanding of when humans first settled in the region and how they lived. In some cases, these methods can even be used to track the population decline of a region. You know, if scientists see signs of increased tree pollen after an extended period of cultivation, they know that the forest reclaimed abandoned farmlands. Of course, palynology is just one of the many tools available to archaeologists. So it must be combined with other research tools to give us a clear view of the big picture. For instance, it can tell us when a civilization left an area. But it doesn't necessarily give us a clue about why the people left. Pretty cool, huh? The only downside of using this method of dating is that it lacks the pinpoint accuracy of some other techniques.
Yeah, I was kind of wondering about that. Nowadays we have radiometric dating, right?
You're one step ahead of me on this.